Happy Monday, biologists. I hope you had a good weekend. Today is Monday, April 13th. Let's get started. So today I want to make sure that we have everything that we need. So you guys are going to need a pencil and a notebook or paper so that you can get this work down. So today we are basically just going to be doing a wrap up of our ideal gas laws and start working on our QPA. And so you need to be able to write with that. So pause me now so you make sure that you have your pencil, pen, or paper, and paper. Okay, welcome back. You should have grabbed your pencil or pen and a piece of paper, either a notebook or free, just so you can write down what we're going to be working on today. So as always, here's my contact information. Please call, text, email me as needed. Comment on this video if you have any questions. So today we are going to be continuing to work on these factors that affect reactions. And our objective for today is I can describe and analyze a gas loss phenomenon by doing research and writing back information on the topic. So first things first, you guys are going to answer, watch this video and then answer questions so I can show you where you should be going and what questions you should be answering. I just exited out of it, so that's a dumb move on my part on accident. So I apologize about that. So you are going to watch this video on the ideal gas laws. So I'm going to put a link in the description, and then this is also going to be on Google Classroom for you to watch a video and then answer these three questions. So when do gas deviate from the ideal gas law? What does STP mean? And what was something new you learned or something that was interesting to you that you watched in this video? So it's not too long, only 9 minutes. So pause the video now to watch that separate video and then answer these three questions on your piece of paper. Okay, welcome back. So you should have completed these three questions and have answers for them written down on your separate sheet of paper. So you should have learned that gases sometimes deviate from these ideal behaviors that we ascribe to them in our gas laws. And you should have learned that STP stands for standard temperature and pressure. So it's just a way for chemists and scientists to quickly write a specific like standard conditions that they're talking about. Scientists can be lazy sometimes, so they like to have shorthand for everything. So that's easy. And then hopefully you found something interesting or something that new that you learned from that video. So we are going to go into our what we learned. So just go over quickly what we learned. So here's a cute little comic. So comment below what's happening here. So it says we're talking about Boyle's law. So if they're going up, they're at the bottom of the ocean going up. Why does their balloon pop? What's happening with their gas laws? As a reminder of what our gas laws are, so in the same sheet of paper that you answered the three questions from the video, you need to be writing this table into your packet or into your separate piece of paper. I apologize, I misspoke. So into your separate piece of paper, or write this. So the gas laws that we learned, so these are the three gas laws that we learned. I am adding a couple here just so you see how they're just, oh, I'm sorry. So they're the same thing. They're just taking versions of the gas laws that we already know and just combining them a little bit. So I will explain what this last one is because it has a couple extra variables that we don't. Well, we're familiar with N as in moles of gas, so the amount of gas that we're using. And then R is just a constant. So it's a gas loss constant that a chemist came up with and that we use to describe the behavior of ideal gases. So we have our gas law over here on the left, the variables that are included. So what specific gas properties are we looking at? The relationship So as one goes up, does the other go down, making it an indirect relationship or a direct relationship? The bottom two don't have that because they're dealing with more than two variables. So we have Boyle's law where we're talking about volume and pressure. So as volume goes up, pressure goes down and vice versa. So they have an indirect relationship. Charles' law is dealing with volume and temperature. So they have a direct relationship, meaning as volume goes up, temperature goes up and vice versa. Gay-Lussac's, we have pressure and temperature. So again, that's another direct relationship. Finally, down here, we have our combined gas laws where we're going to be talking about volume, pressure, and temperature. So it's basically just combining Boyle's and Charles and Gay-Lussac's laws into one. So we still have PV together being multiplied together, and then they're all divided by T. And then our ideal gas law is combining all. So it's setting pressure and volume equal, multiplied together is equal to the amount of moles, which is N. So right now you should take the time. So write N so N equals amount of moles of gas. And moles is basically just the amount of gas that we're using. And then R is a constant, so it's the ideal gas constant. Meaning it's just a constant number that will always be the same in every problem. So basically we're just combining our different laws to create an ideal gas loss constant. So pause me now so you guys can get everything written down here. So pause me to do that. I can write this a little better. Okay, so pause me now to complete your table, a reminder of the gas laws that we learned and a couple new ones. Great. So you guys should have had a chance to write those down. Now we're going to move on. So just as a little reminder, so you guys, I just want to include this PhET simulation so that you guys, we did this probably a month or so ago in class. So just you guys can play around with this to see. I don't have any questions or anything with it since we already did it in class and I don't want to make you guys redo it. I just want you guys as a refresher to play around with it. So this should look familiar. So you add gas into here. It tells you the pressure increasing. You can play around with the temperature. So 300 degree Kelvin is also equal to 27 degrees Celsius, and we should know why. You can decrease the amount of volume. You see how that affects pressure. Increase, same thing. You can play around with, basically this is just playing around with the units. You can make it hotter versus colder. You can pause it. You can play it, or you can pause it and then forward it while it's paused. You can change the type of gas that you're putting in. So down here, you change the type of gas. And you add a bunch of little ones. And you see how they're reacting and how they're bouncing off of each other, right? Oh, and then that's the erase button. So then you can hold volume constant. To hold volume constant, temperature constant, pressure constant, temperature constant, or pressure that's volume dependent constant, pressure that's temperature dependent constant. So you play around with this and basically you're just seeing how these gases are changing when you're manipulating different variables, just as a reminder for you guys. Okay, so you guys are going to be working on the big QPA. So as I've been saying this whole time, for the whole semester, we are going to describe the relationships of pressure, volume, temperature, quantity as it relates to ideal gases. And then gases, so these laws can be applied to a lot of interesting activity and phenomena. So being able to have an understanding of this is an understanding to describe and analyze complex systems. So your assignment is you are going to choose an appropriate phenomenon that showcases a gas law. So it can be any of these here, or if you find a new one. So for example, how hot air balloons work, how scuba diving equipment works, how like the gas tanks work, how flying an airplane, how they have to pressurize the cabin, how that works, airbags. So anything that has to do with gases and you can apply a gas law to is fine by me. You just pick one of these topics and then you are going to research that topic and identify the gas laws that apply. So let's focus on this 1 and 2 here. So by the end of today, by the end of this video, you should pick which one you are going to be working with. You'll highlight it, and then you're going to do separate research on the topic and identify the gas laws that are applying. As always, make sure you are noting the websites that you are going to, because that is going to be important. We're going to make a citations page. So here you are. So do your strong research, create a presentation. You can create a poster and send me a picture if you want, create a PowerPoint, whatever you guys want. However you want to do it, create a video. That's also awesome. So be sure to include background information to tell me about how has it progressed through time. So how did airplanes used to look versus how do they look now? How are they using the gas laws then versus now? Include names, dates, and images. Show me that you know how the gas law is working, how these gas laws are working. How does it relate to your life? Use at least 3 sources and you need to be able to cite them. That's going to be a later video, so don't worry about that too much if you're not familiar how to cite it. So choose any type of presentation that you want. Just make sure you're emailing me with them. So be creative. So we have our guiding rubric down here, so you guys can use this. We're going to be using reason quantitatively and use tools skillfully. And then you have a bottom rubric as well. So you can check this out. I'm not going to go through that too much. So let's get started on doing your research for the topic. So use that separate sheet of paper as well that you already were working on today to create your research. So if you are interested, choose which one you're interested in and then do your research on it. So research the background information here. So be sure to make sure you include your background information and then tell me how the different gas laws are applying to that. And then next time and throughout the week, we'll be talking about how manipulating different variables will change the reaction. So if we add too much volume to a hot air balloon, how does that affect the pressure? How does that affect the temperature, etc. So you guys should be getting started on that. That's going to be posted in the mini QPA and the assignments under the gas laws. So as always, here's my contact information. If you have any questions, email, call, text me, leave a comment on this video, leave a comment on Google Classroom. And we are all set. I'll see you guys next time.